Okay, what's this whole precise definition of a limit? Well, what we're trying to do is get very, very close to this value of interest, which we will call x sub naught. And what we want to do is we want to have, as you can see in the formula over here, we're going to have some distance, this epsilon, and when this gets moved around, what's happening is, of course, you're getting closer and closer to this x sub naught. And this closer and closer are these deltas and minus delta. Okay, so less than or greater than. So looking at, well, just flat out the limit, sorry, that's a little thick, x squared, as x sub naught approaches 1, well, we can see that limit, and that's this value right here, is 1. All right, so using this definition, meaning I'm just going to start plugging things into this piece. So I'm going to have my f of x, which is x squared, minus my limit, which is 1, less than my epsilon. Well, it might be hard to see, but this is 1.2 and 0.8. So it looks like that distance there, my epsilon, is 0.2. And from here, I solve this inequality. So when you have absolute value, you do the plus and minus. So negative 0.2, x squared minus 1, and positive 0.2. Then I would add 1 to all three pieces. So I end up with 0.8 less than x squared less than 1.2. And now finally, I would square root all the pieces to get 0.8944, we'll round it there, less than x, less than 1.0955. All right, so that's this first step. Now we're to the such that, where we want, what we're trying to do is we're trying to center our area, this delta here. So we want to find the smaller of our error. And to do that, let's get a different color so you can tell I'm doing this piece now. I have x minus my x naught, which is still 1, less than delta. I do my plus or minus, x minus 1 less than delta, and now I add 1 to all three pieces. So I have 1 minus delta less than x, and 1 plus delta. What you do from this step is you set these equal to the lower and the upper values. So let's just zoom out a little bit so you can still kind of see what I'm doing. And so I am going to set the 1 minus delta equal to the lower limit, 8944, and I'm going to set the 1 plus delta equal to this upper limit, 1.0955. And if you do the algebra here and solve for delta, you'll get 0.1056, and you will get 0.0955, and you always pick the smaller value because you want smaller error. And so that's the whole process of this finding the precise definition of a limit.